Hello everyone, how are you guys doing? Good, how's everyone? Thanks to Android Summit for giving me a morning session because always like my previous sessions are either at lunch or after lunch. So I could see people are like coming to sleep for my session. So I look all the fresh faces here, so that's nice to know. So before we start, how many of you have used Firebase? Oh, many of you. Okay, so for those who have not used Firebase, don't worry, it's not that complicated. It's just a suite of cloud devices provided by Google to make your life easy so you can implement APIs, you use all sort of cloud devices, and they support for Android, iOS, as well as web. Let's see how it works. It's pretty easy. You just go to the console and you click on Create Project. So it'll give you a project name. That is your Firebase project name. After that, it will ask you either to add your Android app or iOS app or your web app. So the Android app you add, it's going to ask for the app ID. So the app ID is nothing but the same ID you used to upload it to the Play Store. So if you use that app ID, the Firebase will give you a Google Services JSON file. So that's how it's going to recognize your app uniquely. After that, you get that Google JSON Services JSON file, and you put it in your app folder. That's it. Right now, your Android and your Firebase will be able to communicate with each other. It's that simple. Let's talk about MLKit. So what's MLKit? It's the expansion is machine learning kit. I couldn't find a good acronym like Chet had yesterday, so sorry, it's MLKit. You can implement cool AI features without even writing complicated algorithms, especially a person like me who doesn't like writing complicated algorithms, but I want to use all the cool AI features. So you could use that using MLKit. So what are the features we are going to see in this presentation is face detection, AutoML Vision Edge, recognize and translate text, barcode scanning, and smart reply. Let's start with face detection. Would it be easy like you had an app where you can recognize the face, change it to a cartoon character, or change it to a curator, or anything like that, without writing its algorithm and everything, and just call the API and that's going to give you all the values? Would it be cool? Yes, you could do that with MLKit. Let's see how we can do it. You just add the library to the Gradle file. That's the usual thing. Then you configure your detector options. So what is detector options? So what do you want to detect in the face? You want to detect their landmarks, or do you want to detect their contours, or do you want to do some classifications? Those you can do with the detector options. Next, you convert the image. So you can take any sort of image with a bitmap, a byte array, or a URI, and then convert them to a Firebase vision image, because the detector will only take Firebase vision image. So always you have to convert it to a Firebase vision image, and then you give it to the detector. So once it detects, it's going to give you a list of Firebase vision face objects. With that, you can recognize, okay, these are the faces that have been recognized in the response. Let's look at a sample code. Here you can see that I have set my options. So what are these options are? One is the performance mode. That means, do I want it to, when I'm doing a live streaming and detect the face, I want to detect it fast, or do I want to detect it accurate? So fast is the default, so you can pick your performance mode. Next is a landmark. So what's a landmark? Landmark is not that, do you have a building in front of me or a lamppost in front of my face? No, it's your key features in your face, whether it's a left eye, right eye, or it's a left ear, right ear, or it's a lip. That's where the landmarks are. So you can either specify you don't want to specify the landmarks because I'm just going to detect the face, or you can say that these specific landmarks, or I want to specify all landmarks. Next, what's the contours? So what's contour is, like the key features, you will get a set of points. For example, if you have an eyebrow, so you can say that I want the set of points around that eyebrow. So I can get that eyebrow and do changes with that. So either you can say contours or all contours or no contours, and contours is very specific to detect a prominent face. So you have to use one face in the picture. If you're using multiple faces, contour won't work. Next is classification mode, whether you want to find the person is smiling or closing the eyes or opening the eyes. You can specify that using the classification mode. Next one is the tracking. So if you have multiple faces in the picture, you can track them giving them an ID. And this will conflict with contours because contours you can use only one image. So you have to see which one you want to use. Now I set my options. Then I'm setting these options to my detector. After that, I'm taking a bitmap image, I'm converting it to a Firebase vision image, then giving it to the detector. You can see that if a face is not detected, you might think it's going to return an error, but it doesn't return an error. It will return a success response with the list as empty. So here I'm trying to print if the face is detected or not, if the list is empty, no face detected, and if the face is detected, it will return face detected in the text box. Let's see a simple demo of it. Any volunteers want to come and get their face detected?
Me.
Okay. Cool.
Do you mind glasses or no?
You can try with both. Let's see how well it can detect. Sorry. Cool. It was pretty quick. Like the face was detected pretty quick. You may think that I'm tricking it to detect a face. Let's try something else, like with no face. Probably it's going to get a face. Yeah, because you guys were there. I'm just going to go this side and try to take some fruits. So no face detected. And the response was, sorry?
Could you put that in a happy face? Like
Yeah, he's telling you to put the apple. Yeah.
I thought like the apples would be the eyes.
Next time, yeah. If Android Summit invites me next year, I'll do that. Thank you. So let's go back to our presentation. So with this, you can take a simple image like this, and you have all the points, curator points, and the face detection features. You can change a face like this to this, or this, or this. I have copyrights for this because he's my son, so no complaints. Next, I felt like nice to have features was, I'm just comparing with AWS Recognition API, which I've used. It has an API to compare two faces. You do get an tracking ID, but then you have to take the tracking ID and then you have to compare with another face. But I felt like if it would be nice for Firebase to have an API that can also compare two faces. Another one is, right now I took a picture, then I translated to bitmap, but if you're doing a live streaming, you might need a camera source class, and that's not part of the library. It's because they want the library to be small enough, but they do have an example GitHub code where you can download and use it, but I felt like if it's part of the library, it would be nice to use instead of me copying all the class files and adding to my code. Next one is, I didn't see a readable API response. So if you're using, anybody who's used Charles Proxy or Postman, you can always see the JSON object returned, and you can manipulate the values based on that response. But in this, it always gives you 200 success, and that's it. So there's no way, anytime I have to get the code and then use the object and find what are the different values are. Here's a reference link. It's pretty much, their documents are very clean and clear, so you don't even have to go through another place to read the documents. You can just reference their documents. It's very easy. So now we are done with face detection, let's go to the next one, AutoML Vision Edge. So you might have used AI apps where it can recognize, is it a vehicle, it's a human being, or is it a fruit or something else. Would it be nice that you can have your own set of training objects, and without even writing algorithms for that, and you just call an API and ask it to train it, and it can return you the train response? You could do that with MLKit. Let's see how we can do it. First would be, you have to upload your images to the console. So once you uploaded them, you might have to label them. The easiest way I found is you can create folders and put all the images there instead of uploading them and selecting each and each image and giving them a label, add them to the folders, name the folder, and add all the folders to the data set and name it, zip it, and upload it. It will automatically recognize all the labels. This is there in their documentation. If suppose you couldn't find it, I'm just saying it's there. This is the easiest way I found it. Next one is you click on training. So training, it gives you different efficiency training sets. You can pick them. Some are free, some you need to upgrade to get a better efficiency results. And then there's a computing hours. That's 1 hour and 8 hours. 1 hour is free and 8 hours you need to upgrade. Then after it's downloaded, after it's trained, it will ask you either to download the model or upload it to cloud. So if you download the model, it will give you a TF TensorFlow Lite model data. If you feel that's heavy, you can upload to Firebase cloud and you can use them. So once you're done it, you add your local, if you're using the local model, you might have to upload it to your asset folder. And then you set your detector options, which will be whether you want to use the local model or remote model, or what is the confidence threshold. So you can set a confidence between 0 to 1. So that's like if you have uploaded lots of images and you think that your training is very good, you can go and set your confidence threshold to 0.8. Don't even pick anything below that. Just only pick the images which is trained, which is above the 0.8 threshold. After that, again, the same thing. You're taking any image that needs to be converted to a Firebase Vision image, and then you give it to the detector, which will give you results. What probably, if you want the label or you want the confidence level, it will give you those results. Let's look at a quick code. So here is a sample. Here's options I'm setting where I'm setting the threshold value. My threshold in my demo, I'm setting to 0.3 because I didn't well train. I just only took a couple of images and uploaded. So I'm setting like if you can find till 0.3, I'm good enough. And then I'm saying if the remote model works, use it. Otherwise, use the local model. And then I'm getting these models to the detector, then converting my bitmap image to a Firebase Vision image. And then I'm getting the results in a list of labels, and I'm getting the text and the confidence. So here you can see the images. I'm training fruits, so I'm training apple, pear, banana, and mango. And you can see in the left corner, it's giving like a warning sign. It's because I've only uploaded like 20 or like 12 images. It's at least expecting 100 images for each set, so it can well train it. But after training, it's giving me the results. It's saying I'm able to distinguish them 100%. Sometimes if there is a conflict, it will give you the conflict percentage here. So let's see a quick demo of it. Let's see if we can recognize my banana. It did. And it gave me a confidence level of 0.6. You want to try? Let's try the apple. It did. It's also 0.6, not bad. Let's try the mango. It did, with 0.4. So
It's not that confident, right? You think it'd be closer to 0.8 or?
yeah, because I didn't train it that much. So
I see.
so if I given like 100 images and I said I picked only the free computing hours of 1 hour, and there's an 8-hour computation. So if you pick that, it will train and it will do it a better job of training it.
You're saying if you train it for 10 hours, it's going to have a better, if you know what pattern you're feeding it, it'll come up with a better answer.
Yes,
And
with a better confidence level too.
But you're not telling it it's a mango.
I am telling it with a label.
Oh, you told it was a
Yeah, so when I'm uploading it, you can see the labels. I'm setting it up in the, I'm sorry, I have to go back. I set the labels. I said these images are mangoes, and that's banana, and that's a pear, and that's the apple.
Oh, so you had to tag in it?
Yeah, so I'm setting the labels for them. That's how I'm saying that if this is, if you find something like that, that's an apple.
I see.
Cool.
between the Mango and the Clear. What sort of algorithm did you use?
I didn't use any algorithm. I just fed it to TensorLite, and TensorLite is using the algorithms.
That sort of seems like it's cheating. I mean, if
Can
we
we
already.
please keep the question until the end?
Okay, sorry. So this is just, I'm showing it if my demo doesn't work. It did work one time. Let's go to the reference link. This is their reference link. I like their code lab. I started trying the ML Vision with their code lab. In that, they have the flowers. They have 100 of each flower set. And you can download them and upload them to your Firebase cloud, and you can use them. So it was pretty neat. You can try the code lab to start working on Auto ML Vision. So with that, let's go to next to recognize and translate text. So would it be cool if you're in some other country where you don't know the language and you want to take a public transport and it's written something in it? Would it be easy if you just take an image and that image tells you what it is and translates, detects the text in it and translates it? You could do that with MLKit. Let's see how we can do it. First one is recognize text. For that, it would be the same. Either you have to set the options to say whether recognize using on device or on cloud, then set your options to the detector, and then convert your image to Firebase Vision image. And then the detector processes and gives you the text in the image. Next, for translating, you have to set what's your source and target language. And then you set those options to your translator, download the model, and then the detector will translate the string for you. Let's quickly look at the code. So the code for detecting the text, it's almost the same as like you're seeing for other images, where it will convert the bitmap image to a Firebase Vision image, and then you feed to the detector and it will find out. Right now we'll just see for translating the text. So here I'm setting the source language and the target language. It's in English, from English to Spanish, and then I'm setting these options to the translator. Then I'm downloading the model. If the model doesn't already exist, I'm downloading the model, and then I'm translating it. Let's look at a quick demo of it. Let's go here. You can see this. Just want to thank you guys for coming to this talk. So I'm going to take a picture of this and see if it can detect. I think I didn't do a good job of taking the picture, so it's going to get confused. It kind of figured it out, and Tamil is my native language, so I'm going to translate to this Tamil, and it's going to get confused. It kind of said, it says Miga Periya Thena Neel Vali. Okay, it got a little confused. So Miga Periya means it says very big. Whoever understood Tamil, like who knows Tamil, it's very big. After that, it got confused. But I tried it with a clear picture. It was able to recognize it. It clearly translated to Tamil, and it was awesome. And let's see a simple one. Let's take a thank you. It picked it up. Even the exclamation mark. It says Nandri. Nandri means thank you. So if you want to learn a new word in Tamil, it's my native language. So thank you is a word which has been always used. It means Nandri. And Nandri for coming for my talk. Okay, let's go back. Now, keep in mind, if you're not translating to or from English, it's going to use the English as the mediator. So that means, for example, if you're translating from Spanish to German, it will translate the Spanish to English and then to German. And here's a reference link, which pretty much you can just go ahead and use the Firebase links, and they are very well documented. With this, let's go to the scan barcodes. So have you guys used any API to scan the barcodes in your app? I have used, the one thing I've used is Zing, and it's been outdated and it's only in maintenance level. The other thing is Google Vision is available, and they are deprecated, and they are suggesting to use Firebase. So if you're planning to use an API to scan barcode, just close your eyes or even open your eyes and use Firebase MLKit's scanning barcodes. Let's see how we can do it. It's the same thing, like you will have an image and you have to convert it to Firebase Vision image. Next, you have to set what barcode formats you want to scan. Either you want to say, I only want to scan QR code, or I want to scan all formats. Then you set it to the detector, and it will give you the vision barcodes with bounds, corners, raw values, and specific value types. You might be confusing what's raw value and specific value types. In the demo, I'll explain how it distinguishes that. Let's quickly look at the code. So here I'm saying any format, recognize it. But if, as I said, if your app is only using QR code, you can just set QR code. So it will be more efficient. Then you set those options to the detector. And then here I'm converting my image to a Firebase vision image. And here you can see, so it's giving me the barcodes. One thing is I can just get the raw value directly, which is nothing but a string. So if you have a single string uploaded to your barcode, if you want to get it, you can just use the raw value. But what if you're using something like Wi-Fi? You're setting the SSID and password, and when someone is scanning, it wants to give them independently. You can use the value type. So I'm setting here, give me the value type, and if it's type Wi-Fi, separately give me the SSID and password. So you don't have to parse the value of the string and directly use it. Let's look at the demo to see it. So here is the one which is giving me, which will give me the SSID and password if I scan this barcode. So you could see the raw value gives all the values. It says it's a Wi-Fi, and the type is WP, and it says SSID is Android Summit, and password is an awesome conference. But what if I just want the SSID and password? So that's where I use the type Wi-Fi, and I can directly get it instead of getting the raw string and passing each value in it. So which is a pretty neat way you can do it. Let's go back to our presentation. So what is the nice to have? I felt the same as face detection. The camera source is not part of the library. And also, the scanning is really, really fast. So when we implemented it, we were supposed to, once you scan, you're supposed to launch a fragment. It kind of launched a fragment five times. So, so you might have to add a check to like, hey, stop scanning and do it. My thing is if it can pause for a few seconds or like few milliseconds and then scan the same barcode, it would be nice. So that we don't have to add that check. And here's a reference link, which is pretty much you can use the Firebase link, and it's straightforward. Let's go to the next one. It's the smart reply. So smart reply means you have seen always when you're typing in your chat, it will always give you suggestions. So if you're building your own chat or something where you want to give them a suggestion, you can just use Firebase MLKit. Let's see how we can implement it. It's the same thing. You create a list of Firebase text message objects. Then you start feeding messages. So your messages will be either local user or remote user. So local user means, for example, I'm the one who's receiving the messages. I'll be the local user. Then each one of you is sending me a message will be a remote user. So I'll start setting user IDs for each one of you so I can uniquely identify you. So you start adding those messages to this list. Once you're done it, you pass this message to the Firebase Smart Reply, and once it gets this list of messages, it should be able to give you 3 suggested replies. If you only give like a more message conversation, it can give you meaningful suggested replies. Otherwise, it will be very plain. Let's look at the code for that. So here you can see I'm getting the instance of the Smart Reply, then setting the remote user, which has a user ID, and the another one is the local user. It doesn't require any user ID for it. And then you pass the conversation, and you can see it's giving you 3 results, and you're adding to the text box. Let's quickly look at a demo. So in this demo, I have a very simple one, which just gives me the response. So I'm not adding the local user in it, only the remote user. So if maybe, let's see. I say, hello, it says, yes, how are you, and a smiley. Sorry. How are you? Good, fine, I'm good. But if you start adding both the messages and pass the conversation list, it'll give you more meaningful response. Let's go back. Here's a reference link, and also if you want to build a small chat box, you can use this medium post, which I found it interesting because the person will have the remote user on the top, so you can type for both. So remote user will be typing on the top, and bottom will be the local user, and the local user will start to get better responses and suggested replies. So we saw too many features. Was it complicating you? Let's simplify it. There will always be a detector. For example, the face detection, so there's going to be a face detector. For smart reply, it will be the smart reply. For translator, it's a translator. So consider all of them as a detector. So always there have to be a detector, and it always requires an options. So for face detection, what would be your options? Anybody? You'll get an apple if you answer correctly. Nobody wants this apple. Or the dying banana.
I think the face detection, it doesn't know it's you unless you associate name, right? You have to label a face that's you, right?
Yeah, that you can add as a custom ones, but what you want to detect in a face? You want to detect the eye or the nose. Suppose you want to take a face and you want to convert it into a cartoon image. You want to know its key features, right? You want to find where the eye is, you want to find where your eyebrow is, nose is. So those will be your classifications, will be your options.
Well, I'm saying if I took a picture of your face, I'd want to know it's you, your name, right?
Yeah, you can associate a name,
But if-
and you'll associate a tracking ID to it. That's how you'll recognize
You're
it.
going to then take a different picture of you on a different day, right? Then it's going to associate that with pictures already in inventory, right? It has to find the label with your face from
Yep.
a different day,
Mhm.
maybe with different hairdo, but the same face, right?
Sure. Yeah, that's where I was saying I like the compare API, which AWS recognition was doing it. So I don't have to do all this. So right now you have to set the name, store it where you want, and then you have to compare. But there is no API which compares to faces, where it's taking your name today, and tomorrow it's taking a picture of you and comparing and saying, oh, this is you, I found you.
What does that on Google Photos, for instance, like all the pictures for 3-4 years, it actually combines all the pictures and says, hey, we detected one person here.
Okay.
We want to name this person. But I see my nephew's pictures from the moment he was born until he turned 5.
Okay.
So I actually detected like 100 pictures and said, hey, this is one person. Would you like to name this person?
Mhm.
That's how it detects, basically.
The face detection does it? Oh, okay, because I've not tried it that efficiently, so probably it already does it. Okay.
But that's not an API, right? That's just a DAG.
So I don't know if it's API or not.
Yeah, I assume that that's just sufficient.
That's your custom way of building it, right?
What's that?
Comparing the two names.
I don't know what you're asking. I'm just saying Photos is an app. It's not an API. You're
Oh,
right,
yeah.
the MLKit API. So I'm not sure that capability is available to developers.
Thank you. So for example, if you're using a translator, what would be your options? It will be your source language, and it will be your destination language. So now you have set your options. Now you need to feed an input. So input will be a data. So for example, for a translator, your data would be a string. And for smart replies, it will be a list of Firebase objects, message objects. Or it could be an image converted to a Firebase vision image and feed to the detector. So now the detector will give you a result, which will be a list of objects or just an object. To check the processing, here is the list of processing they've given. So you can compare which is done in on-device and on-cloud. So certain on-device or on-cloud processing, you might need to have to upgrade it. Here you can see Firebase console is giving me, this is my app ID, and it's giving me where it is running on it, like all the features which I implemented. And also it's giving, if you want to upgrade it to cloud-based, you can also upgrade it. So with all this, now let's go and start implementing MLKit. Thank you, Nandri. Do you have any questions? Cool. Thank you. Thanks, everyone.